Good morning, students. In the last video lecture, we discussed about the numerical problems related to the nodal analysis for the circuits only with the independent current sources. In this video lecture, we will discuss about numerical problems related to the circuits both independent and dependent current sources. Okay, now so this is a problem, numerical problem related to find the voltages at the three non-reference nodes in the circuit shown in the figure below. So this is a circuit diagram. In this circuit diagram, what is the first step? We have to identify what is a reference node and non-reference nodes. By seeing the circuit diagram itself, we will consider so what are the nodes here and which is the non-reference node. So no doubt here what are the nodes here? The interconnection of this 10 amperes, 3 ohms and 2 ohms. This is a one node, and here 3, 4 and minus so 4ix dependent current source are joined here. So that's why this is a junction. This is a point where these three elements are connected, and here this is a one more node. Okay, so now here 4ix and 2 ohms and 6 ohms are connected. Now here this is a one more node which are commonly connected to this 10 amps 4 ohm resistor and 6 ohm resistor. So that's why this is a one more reference. So here observe here, this is already in the circuit diagram itself they given it a ground, is a symbol for ground. So that's why we will consider this as a reference node. So what is the voltage you have to assign? Here it is a 0 volts for this reference node. Now what about the non-reference nodes? This is a non-reference node 1. So that's why I will consider V1 is the potential at the non-reference node 1, V2 is the potential at the non-reference 2, and V3 is the potential at the non-reference node 3. Okay, proceed in the same manner. So now again, what is the first step? Apply KCL at node 1. So what happened here? We have to identify what are the currents at this node. So here this 10 amperes is entering into the node. So that's why we will assign minus polarity. So already in the last video lecture itself, I explained about how we are going to consider the current directions. It is entering into the node, so that's why minus 10 amperes. Next, what about the his one? Here 3 ohm is connected between the potentials V1 and V2. So that's why what is the potential difference? V1 minus V2 divided by 3. Clear? Next, and at this node 2 ohm resistor is also connected. It is connected between V1 and V3 potentials. So that's why what is the potential difference? V1 minus V3 divided by 2, which is equal to 0. So now by simplifying this, here taking the LCM 3 and 2, we got 6, and this is minus 60, and this is 2 into V1 minus V3 plus 3 into V1 minus V3, which is equal to 0. So now here it is minus 60 plus 2V1 minus 2V3 plus 3V1 minus 3V3 equal to 0. So now we got 5V1. Next, sorry, this is V2. Okay, this is V2. Next, 5V1 minus 2V2 minus 3V3 equal to 60. So this is your first equation for this node 1. Okay, next, coming to in the same manner, apply KCL at node 2. So at this node 2, what are the branches are connected here? 4 ohms and these 3 ohms and this dependent current source. Now proceed in the same manner. Here 3 ohm is connected between the potential V1 and V2. So here I am considering V2 is the higher potential. So that's why V2 minus V1 by 3. V2 minus V1 by 3. While writing the node to V2 I am considering positive. So that's why. Next here 4 ohm is connected between this V2 and reference node. Reference node is 0 potential. So what is the potential difference? V2 minus 0. V2 minus 0 divided by 4. So that's by 4. Next, coming to this, here this is a dependent source. So no issues. So what is proceed with the same current direction. Here this is a current direction. It is entering into the node. So what we are going to assign? Negative polarity. So that's why here minus 4ix. Okay, minus 4ix, which is equal to 0. Clear? So now take by taking the LCM. So here 12 is the LCM, and 4 into V2 minus V1 here, plus 3 into V2 minus 48 Ix, which is equal to 0. Now here by simplifying this, you got minus 4V1 plus 4V2 plus 3V2 minus 48ix equal to 0. So now here minus 4v1 and here plus 7v2 minus 48ix equal to 0. Okay, so now here observe here, this is a one more additional variable is getting. Here only we have v1 v2 v3 here, but here one more additional variable instead of v3 48 ix is obtained here. So that's why. So who is ix? First of all, ix. So what is ix here? Ix value is mentioned in this one. Here this is a dependent source. What it means dependent? Its value will depend on the other parameter. Okay, here what is the value for ix? Ix means ix is mentioned in the circuit diagram. Ix is passing the current flowing in the 4 ohm resistor. So that's why what is the current flowing in the 4 ohm resistor? Okay, so here current direction is also mentioned. What is the direction of this ix? It is current passing from node 2 to the node 2, non-reference node 2 to reference node, this value. So that's why. So what is the ix value I have to assign? Ix equal to, so what is the current direction? Current direction, it is passing from second node to reference node. So that's why. What is the potential difference here? V2 minus 0. Clear all of you? So this is very important. Here current direction is away from this node 2. So that's why when the current direction is assigned here, wherever the always the current passing from higher potential to the lower potential. So that's why V2 minus 0, okay, divided by what is the resistance here? 4. So that's why what is the Ix value? V2 by 4. So substitute this Ix value in this equation. Okay, so what happened here? Minus 4v1 plus 7v2 minus 48 into what is the ix value? V2 by 4. V2 by 4, which is equal to 0. So what happened here? Minus 4v1 plus 7v2, okay, minus 12v2 equal to 0. Clear? So that's why what happened here, final equation is minus 4v1 minus 5v2 equal to 0. So this is the second equation. Clear? So this is the first equation, this is the second equation. So understood all of you how this is this ix value is obtained. Clear? Next, what about this node 3 like this in the same manner. So node 3 means here I will Here I will write. Okay, so here for this node 3, how I are going to this at this node 3 branches are connected here. So V3 minus V1, that is a potential difference. V3 minus V1 divided by 2, divided by 2. Next, we here the current is leaving from this node 4ix, so that's why plus 4ix. And here what is the current? V3 minus 0. So why means 6 ohm is connected between the third non-reference node and reference node 0. So that's why what is the potential difference? V3 minus 0 divided by 6, which is equal to 0. So this is about the problem. And here what is the LCM here? LCM is 6. So that's why here 6, 3 into V3 minus V1 plus here 6 4s are 24 Ix plus V3 equal to 0. So minus 3V1 plus 3V3 plus 24 Ix plus V3 equal to 0. So now by simplifying this, 3V1 plus 4V3 plus 24 Ix equal to 0 minus 3V1 plus 4V3. So who is Ix? Ix value is already we calculated V2 by 4. So substitute here 24 into V2 by 4, which is equal to 0. So minus 3V1 plus 4V3 plus 6V2 equal to 0. So arranging this in the order, 3V1 plus 6V2 plus 4V3 equal to 0. So that's why here this is the third equation. Okay, so by simplifying this these three equations, so this is a this is the equation 1 and this is the equation 2. Okay, and this is the equation 3. By simplifying this we got the V1 value as what is the V1 value? V1 value is 80 volts and V2 value is minus